Okay, from cumene. So first of all, what is meant by the cumene? First of all, what is meant by the cumene? So what is meant by the cumene means here? So cumene is nothing but isopropyl benzene. So what is nothing but the cumene here? Isopropyl benzene is called as a cumene. So what is the structure of the isopropyl benzene means? On benzene ring, okay, on benzene ring, if bond CH bond CH3 bond CH3 is that. So this we can call as a isopropyl benzene. Okay. So when the isopropyl benzene is, it undergoes to the oxidation reaction. When isopropyl benzene is, it undergoes to the oxidation reaction in presence of catalyst. In presence of catalyst here. Okay. So when isopropyl benzene is, it undergoes to the oxidation reaction in presence of catalyst to form as a cumene hydroperoxide. It forms as a cumene hydroperoxide. Okay, it forms as here cumene hydroperoxide. So peroxide means in between the oxygen it is having single bond. So this only we can call as a cumene hydroperoxide. Cumene hydroperoxide. Okay, after formation of the peroxide, it undergoes to the hydrolysis reaction. Okay, it undergoes to the acid hydrolysis reaction. That means hydrolysis in presence of acid. Which acid we are taking means dilute sulfuric acid. If you add sulfuric acid means here, it undergoes to the rearrangement reaction. It undergoes the intramolecular rearrangement reaction and it forms as a phenol. Okay, it undergoes the intramolecular rearrangement reaction. Sir, how it is going to form as a rearrangement reaction means here, let us see ma. When here in between the oxygen more electron density it is there. Okay, here carbon is gaining these 2 electrons from here. So carbon is taking the electron. This carbon is abstracting the electrons here. That time carbon also get as a more electron density. In between that one to have a repulsions to overcome that one to become as a stable molecule. So this one is it undergoes to the unsymmetrical cleavage. So when it undergoes to the unsymmetrical cleavage means it comes as a OH minus and oxygen is get as a positive charge. Okay, and carbon is get as a positive charge. Carbon is get as a negative charge. In between the carbon and oxygen, it forms as a double bond. In between the carbon and oxygen, it forms as a double bond. CH3 bond CH3. And so on benzene ring, you will get as a positive charge only. Na? On benzene ring, you will get as a positive charge. Whenever you get as a positive charge means here, the positively charged carbon is attaches with the negatively charged OH minus. Then only it forms as a phenol. Then only it forms as a phenol. Sometimes they're asking the question here. In the preparation of the phenol, okay, in the preparation of the phenol from the cumene, what is the byproduct it is formed? In the preparation of the phenol from the cumene, what is the byproduct is formed? So what is the byproduct it is formed, Rama? So what is the name of this one? One is the phenol. What is another one here? CH3, C double bond O CH3. What we can call CH3, C double bond O CH3? What is the name of that one? So this we can call as acetone. What is the name of this one here? Acetone. So now you got the clarity. So this is one of the important reaction here. Okay, sometime in JEE level there also they are asking the question here. So now you got the clarity here. So from how we can prepare the phenol means here, from cumene also we can prepare as a phenol. Sir, what is mean by the cumene? Sometimes they're asking the question. What is mean by the cumene? So cumene is nothing but isopropyl benzene. Cumene is nothing but isopropyl benzene. Now we got the clarity. Samhita?
Yes, sir.
Is any doubt is there?
No, sir.
Mechanism? No, na? I'll go for the next. Okay. And yesterday we are discussing about the physical properties. So what are the physical properties means here? So we are talking about the alcohols. Okay, so lower alcohols are colorless liquids. Some alcohols are having characteristic smell. Okay, some alcohols, higher alcohols are solids, they are odorless. The carbon chain length is going to be increases means here. Okay, so their smell also is going to be decreases. The carbon chain length is going to be increases means here, smell also is going to be, odor also is going to be decreases. And soluble TPC means lower alcohols are highly soluble in a water. Why they are highly soluble in a water means because of they form as an intermolecular hydrogen bonding. So whenever they form as an intermolecular hydrogen bonding, okay, whenever they form as a intermolecular hydrogen bonding, solubility also is going to be increases. Okay, so if the here once you check out here for that one already we had seen some reactions now. Some more structure is mixing up. Neopentanol. Neopentanol is we can write as here like this. Neopentanol. Okay, N-pentanol, isopentanol, and neopentanol. If you compare the N-pentanol, isopentanol, neopentanol, which one is having the greater the boiling point? So solubility. This one is strong, but you won't get here. So which one is highly soluble in water? For example, if they had given methanol, ethanol. Okay, I don't want to disturb this one. If I'm going to disturb means it's going to be whole structures are going to be disturbed. Why the lower alcohols are highly soluble in water now? Anyone of you can you tell me that? Why the lower alcohols are highly soluble in water? Samita? Solubility depends upon what? Right, ma'am. Now you look at the clarity. Samita, are you getting my voice or not? Aditi, are you getting my voice?
Yes, sir.
Yeah, ma'am. So because of I'm thinking that your screen is going to be stucking, that's why I'm asking here. That you are getting my voice. Right. If the carbon chain length is going to be increases, means solubility is going to be increases or decreases? The carbon chain length is increases, solubility is going to be increases or decreases? Got my question or not? If the carbon chain length is increases, solubility is going to be increases or decreases? No one is going. What happened when the carbon chain length is increases? The lower alcohols are highly soluble in a water because of they form as an intermolecular
Can you hear
hydrogen.
my voice?
So I didn't get your voice. Now you're getting. Now I'm getting your voice.
So can you repeat again? I wasn't able to hear you.
If the carbon chain length is increases, solubility is increases or decreases?
Sir, will it increase? Because it will, the chain
Car-
length is,
Carbon chain length is increases, ma. If the carbon chain length is increases, what about the solubility? So what is the example means here already I had given methanol, ethanol, propanol. So which one is highly soluble in a water? That is my question.
no, sir, the chain length increases, the solubility decreases.
Very good, ma'am. Because of non-polar character is going to be increases. Okay, and we are discussing about the boiling point temperatures. If you see boiling point temperatures means here alcohols are having high boiling point temperature while comparing with the carbonyl compounds, aldehydes, ketones, ethers, and hydrocarbons which are having similar molar masses. Okay, so why the alcohols are having high boiling point temperature is because of they form as an intermolecular hydrogen bonding. Okay, so when they form as intermolecular hydrogen bonding means here they form they are having high boiling point temperatures. So due to that reason only alcohols are having high boiling point temperature than aldehydes, and aldehydes are having greater boiling point temperature than ethers, and after that hydrocarbons. Hydrocarbons are having least boiling point temperature. Okay, now and boiling point temperature is depends upon the surface area. Surface area is going to be increases means their boiling point temperature also is going to be increases. Okay, so next the important concept is my here chemical properties. Actually, this we are going to study under the chemical properties of the alcohols here. Okay, so chemical properties of the alcohols. So chemical properties. What are the chemical properties? First, chemical properties means here chemical properties. So what are the first chemical property means here? Alcohols are acidic nature. Is it correct? The statement is correct, ma? Alcohols and phenols are acidic in nature. Alcohols and phenols are acidic in nature. Acidic in nature. Okay. Acidity of the alcohols. Acidity of alcohols. Alcohols is directly proportional to the Ka value and inversely proportional to the pKa value. Acidity of the alcohols is directly proportional to the Ka value and inversely proportional to the pKa value. At the same time, acidity of the alcohols is directly proportional to electron withdrawing groups and inversely proportional to electron donating groups. Okay, so how we can explain the acidity? What is meant by the acidity? What is meant by the acid? So what is meant by the acid? Samhita. What is meant by the acid? What is meant by the acid? Any one of you? Aditi, what is meant by the acid?
So can you repeat again?
What is mean by acid?
So something that which on dissolving in water releases H plus ions, dissociates into H plus ions.
Very good. The substance which releases the H plus ions in the aqueous medium is called as a acid. Okay. Now, alcohols also, whenever you dissolve in a water, they releases the H plus ions. But if you see, means alcohols are weak acids. Now, okay, shall we compare something here? Okay, shall we see something here? So here we have the alcohols are there, phenols are there, and water molecule it is there. Okay, so now you can check it out here. So first I'm going to write as a phenol. First, I'm going to write as here phenol and water molecule H2O and alcohol. Alcohol. So, which one is more acidic in nature? In phenol, water molecule, alcohol. So, which one is more acidic in nature?
Sir, I think water is more acidic in nature, right?
This only one. For that reason only, above one I had given clear statement. Acidity is directly proportional to the Ka, inversely proportional to the pKa, and directly proportional to the electron withdrawing group, inversely proportional to the electron donating group. First, you can draw the structure here. What is the structure means here? It is the phenol. Okay, phenol is nothing but, so benzene ring is attaches to the OH group and water molecule. Water molecule, how we can write as here? Water molecule is we can write as here H2O. Okay, and alcohol. General formula of the alcohol is R bond OH. Now here also on oxygen atom we have a 2 lone pair of electrons. Here also in water molecule also oxygen is having 2 lone pair of electrons, and phenols also oxygen is having 2 lone pair of electrons. My question is, in phenol, water, alcohol, which one is more acidic?
Phenol?
Very good, Samhita. So why the phenol is more acidic? Did you remember the electron withdrawing groups?
Yes,
You
sir.
remember the electron withdrawing groups? What are the strong
OH,
electron with
NH2.
NO2, mine NO2 and
NH2?
CN? Okay. N
Sir,
NH2
what
is
is
the
NH2
electron
then?
donating group. NH2 is the electron donating group.
Okay.
NH2 is the electron donating group. Okay, and we can take as a halogens also electron withdrawing group. What are the halogens we can take means here? Cl, Br, and I. Sir, how we are going to explain the acidic strength of the alcohols, phenols, ethers means here? So based on the inductive effect and mesomeric effect. So how we are going to be explain means here? So based on inductive effect and mesomeric effect, we are going to be explain the acidity of the alcohols and acidity of the phenols. So okay, so electron withdrawing groups. In this one, phenyl is we can consider it as a weak electron withdrawing group, and hydrogen also we can consider it as a weak electron withdrawing group. Now, here electron withdrawing groups are increases, their acidic strength is going to be increases. Okay, and electron donating group generally we can call electron donating groups. Sir, which we can take as electron donating groups means here electron donating groups are nothing but here alkyl group R, alkyl group, and amine, primary amine, secondary amine, tertiary amine. Okay, R bond NH2, R bond, R2 bond NH, R3 bond N, OH, OCH3. So all these are the electron donating groups. Okay. Now here, one more thing also we can write. What is the electron withdrawing group? We can write as a CHO, COO, COOH, and C double bond O. Ketone also act as electron withdrawing group. You have to remember this concept. If you remember this concept means this one is very easy. Okay, so we are applying the concept only here. So acidity is directly proportional to the electron withdrawing group. In this one, R is electron donating group. Okay, and hydrogen and phenols are the electron withdrawing group. In that one, hydrogen and phenol, if you compare which one is the strong electron withdrawing group means here, phenol is the strong electron withdrawing group. Greater the strength of the electron withdrawing group, the acidic strength is going to be increases. So due to that reason only, sir, how it is acidic strength is going to be increases means here. Let us see. In phenol, okay, in phenol, whatever the lone pair of electrons are there on oxygen atom, they involves in a resonance. Whenever they involves in a resonance means electron density is going to be decreases. If the electron density is going to be decreases means H plus ions are easily comes outside. Okay, H plus ions are easily it comes outside. Okay, now here what happened? Alkyl groups are they're giving the electron density here. Already oxygen is having the two lone pair of electrons. Again, if it is give to one more electron pair means here greater the negative charge is there. Okay, greater the negative charge means this have the strong attraction forces between the oxygen and hydrogen. So that time hydrogen does not comes outside easily while comparing with the phenol. Got it all of you?
So could you explain that again?
Once again, can I repeat ma? Right. So here, first of all, I would like to write the structure of the phenol. So this would be called as a phenol. Hydrogen is there. Here also lone pair of electron. Here also lone pair of electron. Is it right? Okay. Now, as per the Aditi now only she gave the one statement. Sir, acids are nothing but the substance which releases the H plus ions is called as an acid. What is mean the acid? The substance which releases the H plus ions is called as an acid. Is that clear? In aqueous medium. Okay. Sir, how they can releases means here, if the electron density is decreases on the oxygen atom, they easily releases the H plus ions. Okay, electron density is going to be decreases means here they releases the H plus ion. Now everywhere, as per you were telling that on every oxygen atom it has a two lone pair of electron. So how the electron density is going to be decreases means when these pi electrons are shifted on this carbon atom, this carbon get as a negative charge, this carbon get as a positive charge. Okay, so to positively charged carbon atom is it abstract the lone pair of electron from the oxygen. Okay, so that time it forms as a double bond. Oxygen is losing the two electrons now. That time we can represent with the positive charge. Now electron density is decreases or increases ma? Samhita. Electron density is decreased or increased in this structure? Samhita, I didn't get the answer.
Decreases?
Electron density is decreases. Electron density is decreases means easily it can remove the H plus ions now.
Yes, sir.
Okay. Now let us see. Here it is having only one lone pair of electron, but here two lone pair of electrons are there. Here three lone pair of electrons are there. Seriously, if you observe means in the first structure, phenol is it undergoes to the resonance. That time oxygen is having the one lone pair, and water molecule is having the two lone pair of electrons. In halo alcohols, aliphatic alcohols, three lone pair of electrons are there on the oxygen atom, where it is having the more electron density. Which one is having the greater the electron density? First one, second one, or third one?
In phenol, sir.
Phenol. Okay, electron density is less at phenol and electron density is more at alcohols. So clearly to make you understand, do you have any idea about the tug of war game, Samhita?
Yes, sir.
Tug of war game. Okay,
Yes.
if you remember now. So here actually you can write as, so it is a thread, it will be there. This side some person, this side some persons, it will be there. So here also 2%, here also 2% are there. If both are having equal number, here both sides they are having equal number of personalities and they're having equal energy. If they're having the equal energy means who's going to win? No one is going to be win now. The game is going to become as a draw. Okay, the game is become as a draw. Now in the second condition, what I'm telling that means here, in the second condition, so one side three members are there, other side we have only one member. Who's going to win? This consists as a, this consists as a B. A team is going to be win or B team is going to be win?
B team.
B team. So why the B team is going to be win, ma?
Has more people.
Oh,
As there are
similarly,
more people.
yes, ma. Similarly, here also once you check it out, in alcohols, what happened? Three members, three lone pair of electrons are there. They strongly attracting the H plus. If they strongly attract the H plus, means H plus easily does not comes outside now. So due to that reason only, alcohols are weak acidic. But in this one, once you check it out here, in this one condition, what happened in phenol? Phenol is having only one lone pair of electron. If only one lone pair of electron means it loses the game now. 18 is going to be loses the game here. 18 is going to be loses the game here. So because of there is no strength. So that's why here H plus ion is easily comes outside. Okay. Now we got the clarity.
Yes, sir.
Can I give one more example to you for this one? Okay, according to the statement. Okay, according to the statement, I'll give one more example, ma. So what is another example means? Already we had seen these examples while discussing the GOC, electron displacement reactions, aliphatic alcohols. For example, CH3 bond, CH2 bond, OH, and CH3 bond, CH bond, F bond, OH, and CH3 bond, CH, CH2, this one is attached there, CH2 bond OH. So which one is more acidic in nature? Which one is more acidic nature? In these three, which one is more acidic? First one, second one, or third one?
Sir, I think second one.
Second one is more acidic. So because of electron, the distance between the electron withdrawing group, functional group is less, then it becomes as a more acidic. Okay. Then after that, second one is more acidic. After that, what is the next one? Either first one or second one?
Third one.
Third one. Sorry. Third one. After that, least acidic is here. First one. Okay. So you got the clarity. The distance between the electron withdrawing group and functional group is increases. Acidic strength is going to be decreases. Okay. So here what we can say means here distance is increases. Acidic strength is going to be decreases. Now we got the clarity. And one more question here. So what is the another one means here? For example, CCl3 bond CH2OH and CF3 bond CH2OH. So in these two, which one is more acidic? In these two, which one is more acidic?
Fluorine, sir. So second.
So how you are telling that fluorine is the more acidic?
Because fluorine has a higher electron withdrawing tendency than fluorine.
Non-electron withdrawing group. If we compare with the halogens, means fluorine is having more electron withdrawing group. Fluorine greater than chlorine, chlorine is greater than bromine, bromine is greater than iodine. Sometimes if they're asking the question like this here. Okay, so here F C2H5OH, okay, Cl CH2 bond OH, and Br CH2 bond OH, and I CH2 bond OH. So from fluorine to iodine, acidic strength is increases or decreases? From fluorine to iodine, acidic strength is going to be increases or decreases? Any one of you?
So fluorine is more electronegative, so fluorine will be more acidic compared to iodine.
Okay, so then from what is my question is from fluorine to iodine, from first structure to last structure, acidic strength is increases or decreases?
From fluorine to iodine, acidic strength decreases.
Decreases, ma. Very good, ma, here. Okay, so that means which one is more acidic? Means here fluorine is more acidic, after that chlorine, after that bromine. Okay, so because of electron negativities decreases. If electron negativities decreases, means the acidic strength also is going to be decreases. Okay, and one more question here. So what is another question means here? For example, CCl3 bond CH2OH and CHCl2 bond CH2OH, CH2Cl bond CH2OH. Okay, So which one is more acidic in these three structures? Aditi? Aditi, I had given three alcohols. Triethyl alcohol, diethyl alcohol, chloroethyl. So trichloroethyl alcohol, dichloroethyl alcohol, chloroethyl alcohol. Which one is more acidic in nature? Aditi.
So trichloroalcohol?
Very good. So trichloroalcohol is more acidic in nature than that of here dichloro and chloro here. So because of number of electron withdrawing groups are increases. Acidic strength is going to be increases. Acidic strength is going to be increases. And one more question here. I will ask. Samita. First of all, I wrote as a three types of the alcohols. So which one is primary, secondary, tertiary? I wrote as a three types of alcohols. In that, which one is the primary, which one is the secondary, and which one is the tertiary? Aditi? Which one is primary, which one is the secondary, which one is tertiary?
So the first one is primary, the second one is secondary, and the third one is tertiary.
Okay, primary, secondary, tertiary. Okay. In these three, which one is more acidic? Which one is more acidic? That is my question.
Third, the first one because it has least number of electron withdrawing groups.
Aditi, something statement is going wrong. Which one is more acidic? That is my question. The primary alcohol, secondary alcohol, tertiary alcohol. Here, primary alcohol is more acidic than secondary alcohol. Secondary alcohol is more acidic.
So that's what I said. Primary alcohol is the most acidic.
Yeah, okay, then. Okay, so primary alcohol is more acidic than secondary. Secondary is more acidic than tertiary. Okay, so why the primary alcohol is more acidic, Aditi?
So because it doesn't have any electron withdrawing groups. Like
second one?
So second one, it's less because there are more electron releasing groups, that is methyl
Yes.
group.
Yeah, actually what we have to compare means after the CH2OH, whatever the group it is that is the electron donating group. Here one electron donating groups are there. Here two electron donating groups are there. Here three electron donating groups are there. It is inversely proportional. Number of electron donating groups are increases. Their acidic strength is going to be decreases. Okay, here three electron donating groups are there. Three electron donating groups means less acidic. Okay, so 1, 2, 3. According to that one, which one is more acidic means here primary alcohol is more acidic than secondary. Secondary is more acidic than tertiary alcohol. Have you got the clarity? All of you? Still anyone is having doubt? No, na? Right, ma. Now, so we will see, ma. Here, acidity also we can explain the based on the reaction. Okay. For example, all acids are they react with metals. Acids are they reacts with metal. Acids are they reacts with metal or not? reacts with metals. Okay, so which metal we are taking means sodium metal. Is alcohol also reacts with the sodium metal or not means here? They reacts with the metals. Which one means here? For example, ethyl alcohol, C2H5OH. C2H5OH is reacts with the sodium metal. Okay, sodium metal means it forms as a C2H5ONA plus half H2. Okay, so it releases the hydrogen gas. So because of acids are when they react with metals means they releases the hydrogen gas. Based on that one also we can say the alcohol is acidic in nature. Okay, then if C2H5OH is reacts with sodium hydroxide. So what is the products it is going to be formed? Ethanol is reacts with the base. Ethanol is reacts with the base. What is the product it is going to be formed? Any one of you. What is the product it is going to be formed?
C2H5Na plus H2O.
C2H5ONA plus
H2O.
H2O. Because of acids, they releases the H plus ion. That H plus ion is combined with the OH minus ion, they form as a water molecule. And it forms as a sodium ethoxide. Okay, and one more reaction. If C2H5OH is reacts with methyl magnesium bromide, CH3MgBr. Any one of you can guess the answer? What is the product it is going to be formed? When the ethanol is reacts with the methyl magnesium bromide, the ethanol is reacts with, what is the product it is going to be formed? The product forms as a methane, CH4 plus Mg bond Br bond OC2H5. Sir, how you are telling that means ethanol is acidic in nature. That means it comes outside in the form of H plus and C2H5O minus. And in this one, metals are having the positive charge. Alkyl group is get as a negative charge. Negatively charged carbon is attaches with the H plus and negatively charged ion is attaches with the Mg. Then if CH3 is converted into the CH4 only now, that is converted or not? Then CH3 is going to be converted into CH4. Now we got the clarity. Preparation of the alkenes, we can use this reaction. Preparation of the benzene also we can use this reaction. Got the clarity or not? Samhita, Aditi?
Yes, sir.
Okay. So right.
Yes.
Then the remaining chemical reactions we can discuss tomorrow. Okay. Right. See you in the next class.
Thank you, sir.
So you're welcome.